Okay, here we go. 5-1 word PowerPoint. Do you all see that?
I see it.
Okay.
Yeah.
So when I say do the following questions from the textbook, just remember that's for your own practice. I'm not expecting any of them. And then as you see, I put some videos here. We're gonna go over things that are necessary in class, but then I suggest that you watch these videos after class. Okay. Here we go. So just page through the PowerPoint. We're going to talk about discrete random variable, continuous random variable. We're going to talk about probability. And then, so just look at some of the things and like P of X being between 0 to 1. Maybe these are the things you have seen in the past few weeks in our class. And then graph. We are not using the formula, although I put it there because we don't need them. And then job interview mistake. We're going to talk about mean variance of probability distribution, but not with the formula. I will give you a calculator comment. So that's pretty much what we're going to do for the first part today. 5.1 and 5.2 are part of the curriculum of the course. Probability distribution for the first half of the course class today, and binomial probability distribution for the second part of the class. Okay. This section introduced the concept of a random variable and the concept of probability distribution. So if you remember, we had distribution, table of distribution in the past, graphing, histogram. So we're going to do that with probability now. And probability histogram. Then we're going to use our calculator to find the important parameters about mean, standard deviation, and variance of probability distribution. And then we're going to talk about if the outcomes are significantly low or significantly high. Okay, let's just talk about some of the definitions. I'm not going to the PowerPoints in a very detail, but then we're going to go to practice. So a random variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. So a random variable, we normally write it with X, has a single numerical value determined by chance for each outcome of a procedure. So please have these definitions written as we move on. Okay, next. The discrete random variable. So when it comes to random variable when we said random variable, it could be discrete, it could be continuous. We're gonna go over both definitions. I look at probability distribution before discrete. A probability distribution is a description that gives the probability for each value of a random variable. It's often expressed in a format of a table, formula, or graph. So let me show you an example. Okay, this is do you see the table? That's an example of probability distribution where you have X defined to be the number of heads when two coins are tossed. So you can toss two coin and 0 times you get head, 1 time you get head, or 2 times you get head. Both, it means none of the coins to be head, one of the coins to be head, or both to be head. This is, and the probability is on the other side. So this is called a probability distribution. So probability distribution, you can say description given or expressed by table, formula, or graph. Could be in form of a graph like a histogram. Okay. Now we have two kinds of random variable. Random variable that are countable, we call them discrete random variables. And we have like tossing coins. You can count 0, 1 number of head, 2 number of heads, depending to how many coins you have. Or continuous random variable where you cannot really count the numbers, like their body temperature be greater than 97 degrees. So it could be 97, 97.1, 97.11, 97.2, whatever. So it's not countable. So read the definition for discrete, and then if you want to take a note, and I'm going to go to continues as well. Okay. So anytime think of discrete random variable, and in this chapter, in chapter 5, we specifically talk about discrete random variable. Starting chapter 6 on, especially chapter 7, we only talk about continuous random variables, where you would say what is the percentage or probability of selecting someone that their height is greater than 5'4", 5'4", for example. So height, measurement of body temperature, body weight, measurement of things like that are continuous, and we talk about them after chapter 6. If you want to take a note of this one for a minute. So please take a note, even if it's a short note, so you know what we are doing. Okay. So there are some criteria that needs to be met for probability distribution. When you're having a table, when you're having a histogram, and you call it a probability distribution, there is a numerical random variable x, and the number values are associated with corresponding probabilities. So it means if you have this table right here, The items under X are numerical. So 0, 1, 2. Do you see my screen? The table? So this means numerical values under X that are associated with some probabilities. The sum of Px. So add all the probabilities here and tell me what you get. 0.25 plus 0.5 plus 0.25. All of you add them up and chat it with me. What number do you get? So please make yourself available to type and write the answers. Great job. Awesome. So I see that you have the outcome that is 1. Great. So when you are adding the probability, when you are adding all the probabilities in the table, it should be 1. It's okay to be close to 1, like 0.999 is okay, because when you are talking about probability and rounding, things like that may happen. So it should be very, very close to 1 or 1. Okay, and every probability must be between 0 to 1. Must be between 0 to 1. So means if you look at the table, 0.25 is a number that is greater than 0, less than 1. 0.5 and 0.25. Okay. So now let's consider this problem. You have 2 coins. You toss it at the same time. Number of heads are your favorite. So the chance of rolling both 0, it's 0.25. So I mean both heads, no heads, sorry, 0, it's number of heads. So rolling it 0 heads, 1 head, 2 heads. So you are tossing 2 coins. The chance that you get no head is 25% or 0.25. The chance that you get 1 head and 1 tail, because head is our favorite and 1 head, is 50-50. So when you're tossing, you're expecting 1 to be head, 1 to be tail. That's 50-50 chance. And then the chance of getting both heads is the same thing as the chance of getting both tails. That's why it's 25% again. 0.25. Okay, so please copy this table because we're going to use to answer questions. Okay, so again, X is defined as numerical, the number of heads. So the criterias are met. We checked that already. X is a numerical value. The sum of PXs are all 1. And each of the PXs, 0.25, 0.5, and 0.25 is a number between 0 to 1. Okay. It satisfies the requirement. Now let's graph a histogram for it. I'm going to just graph that histogram. Let me just do it on OneNote. So you have the table as 0, 1, 2 for the x and p of x to be 0.25, 0.5, and 0.25. When you are graphing the histogram, Normally, probability of x is the vertical. So do you all see the one note that I'm sharing and I'm drawing on?
Yes.
Thank you. So 1, 2, and 3, sorry, 0, 1, 2 are the items I have. 0, 1, 2. Normally, the horizontal one represents x. So on the px, we have 0.25, 0.5. You could have gone to 0.75 and 1, but it's unnecessary in this case. So around 0, you go up 0.25. Around 1 is 0.5. And around 2 is 0.25 again. So that's the histogram. This is telling you that when x is 0 means no head, 25% of chance of getting no head. 1 head, 50% chance. And 2 heads, 25% chance. Okay, so that's about the histogram here. And that's the histogram on the OneNote, on the PowerPoint. So let's do another one. Let's do this example. So read the question. Hiring managers were asked to identify the biggest mistakes that job applicants make during an interview. And the table below is based on the responses. Does the table below describes a probability distribution? So I want you to look at here and tell me why is not a probability distribution. So I'm going to allow you to write in the chat. Please respond. This is a way that I know that you're participating and you're listening and you're asking questions and you're active. So please respond. Just look at there are two problems here that makes it to be not probability distribution. So please write them to me. So there are two mistakes. Even if you see one of them, just tell me, but then so great. Great. Many of you got some of the probabilities more than one. So that's great. It has to add up to 1 and it's over 1. Perfect. Now, I want you to tell me what is the second problem with this. Go back to the criteria. Excellent, Andrew. You got it. Let's see if anyone else can think about it. Send it in private chats and then we're going to share the idea. Go back to the criterias of probability distribution and tell me what is the second problem. So the sum is over 1, so that was one mistake. Many of you got it. Now find the second problem with this distribution. Excellent, Tammy. Excellent, Mazen. Very good. Excellent, Oyindam Mola. Okay, now let's share the idea together. So the things under X, They are categorical data. You are expecting to be numerical. So one of the things was to be numerical. Categorical is not making it probability distribution, because how would you find the mean, or how would you find um, the standard deviation of such distribution if you're talking about categorical? So it's numerical. It has to be numerical. Okay, so now let's go to the next. And one more question. Do you see when I wrote on the page now?
Yes.
Okay, great. So let's go to the next. Okay. Remember that with the probability distribution, we have a description of a population instead of a sample. So the values of mean and a standard deviation and variable are parameters, not statistics. So with probability distribution, we talk about population, describing population, not sample. It's not that you toss the coin two times and say, let's just write the result. This is the general for the population. As you were probably tossing the coin 1,000 times, you would say 20%, or two coins 1,000 times. You would say that 25% of the time you have no head, 50% of the time you have one head, and 25% of the time you have two heads. That's for the population. So now we're going to talk about calculator commands. We are not using formulas. So we're gonna use calculator commands here. Do you all have your calculator with you today?
Yes.
Okay, great. Okay, one more time, because I want to know how many of you have the calculator. I want you to, in a private chat, tell me if you have your calculator with you right now, because we're going to work. So, and I'm expecting everyone to respond, yes or no. Without calculator, almost the rest of the class is meaningless. I mean, it's impossible with the formulas to process it in a 2-hour test. And that's not the goal of the class. I mean, just running formulas. I want you to be able to use some tools other than paper and pencil. And any company you go and work for, they would have calculator, or they would have some sort of devices that you need to enter the data and then run some calculation if that's necessary. Okay, great. It seems that almost all of you have it. I didn't receive any no, which it's okay if you send me no. Not that I'm penalizing you today if you don't have it, but I just want to help you to find the right one. Mustafa, you're asking me, oh, what was the other issue? The other issue was that the items were categorical data and not numerical. So do you see for this one, it's 0, 1, 2 for a coin, but with the manager hiring, it's inappropriate attire, being late, lack of eye contact. So these are not numerical. So numerical is another criteria. Okay. Okay. So let's go here. And let's find mean and a standard deviation. Okay, grab your calculators. In L1, put 0, 1, 2. In L2, put 0.25, 0.50, and 0.25. Let me just bring it to my calculator as well. Oh, I guess this one. Was anyone successful downloading any app for TI Calculator? Just send me a private chat so I can also share it with those who don't have it. Were you able to download the app or not? I purchased this one. This is a license that I purchased, but I'm just asking in your case. So go to so so let's go to stat, edit. In L1, again, remember if you have items in there, second, clear, down. I think even if you say clear down, it's gonna clear it. Yes, yes. I think if you say clear down, it's gonna clear it to 0, 1, 2, 0.25, 0.5, 0.25. Okay, then you go to stat again. You go to calc, 1 var stat. Frequency list, please put L2. In order to type L2, so list in L1, frequency in L2. To type L2, you go second and number 2. Do you see here L2? And then if your calculator is type of an older one, so you would say 1 var stat, open parentheses, L1, comma, L2, and then enter. So here we go. So we have mean to be 1. And sigma standard deviation for the population to be 0.707. You see that? Because they don't have mu here, it's the same thing for reading the calculator. That's the mean for the population. And also standard deviation is 0.707. And then to find sigma square or variance, you just square sigma. So 0.707 square. I don't know what happened with my pen. Okay. So you don't need the rest of items here. Any question? Were you able to find it? Okay. You mean how do I find L2? Is that what your question is? How do I type L2? L2 is the probability. L1 is 0, 1, 2. L1 is X. Under L2, you put the probability, 0.2. Like if I go to stat, edit, under L1, I have 0, 1, 2. Under L2, I have 0.25, 0.5, 0.25. Make sure you have the same outcomes as mine. Okay, as you see here, the mean number of coins to be tossed means in average, you get 1 head. So when you are tossing 2 coins, in average, you get 1 head. The variance is 0.5, the standard deviation is 0.7. In order to go from 0.7 that we got on our calculator, so as you remember, we went to stat here, and I said put L2 for the frequency or open parentheses L1, L2. We got a standard deviation to be 0.7 or 0.707. When you square 0.7, what do you get? That's going to give you the variance. Put it to your calculator. What is 0.7 squared? That's the variance. So you have the mean, you have the mu, you have the standard deviation for population. We said everything is for the population here. So, and then here it is. If you have 0.7 squared, the key for a square is that red button here. So that's about 0.5. Yes, 0.49. If you put it like 0.707, it's even more accurate. But 0.49 is well close to 0.5, but you get even closer to 0.5. Okay, so let's talk about what being significantly low or high. So significantly low values are, you remember, 2 standard deviation below, 2 standard deviation above. So mu plus 2 standard deviation above and below is not significant. Anything outside that, it is significant. So in this case, mu was 1. 1 minus 2 times 0.7 and 1 plus 2 times 0.7. Anything in between that is not significant. So that means 1 minus 0.14, that's 0.86. And then above is 1 plus is 1.4, that's 2.4. So it's impossible to get more than 2 heads, but if you were getting 2.4 heads or more, then that was significantly high. Getting, oh, hold on a second, 1.4. 2 times 0.7 is 1.4. And then you don't have negative number of heads, but if you were getting below negative 0.4, it would have been significantly low. So 2 standard deviation above and below. Anything in between, so that means that 0, 1, and 2, none of them is significantly high or low when you get them in tossing coins. What did I type after I went to one var stat? Oh, L1, L2. If you have, do you have an older calculator or newer calculator? You go to one var stat, you take the number, the first one. So basically you go to stat, you go to calc, one var stat, list L1, frequency L2. If your calculator doesn't have this, you open a parentheses, you write L1, comma L2, close the parentheses after one var stat. Before you say like enter, you would say one var stat, open parentheses, L1, comma L2, close parentheses, and then enter. Once you do that, your answer should be same as mine. X bar is the same thing as mu in this case. And then sigma of x is the standard deviation for the population. Any other questions? Okay. So they did the same calculation with it. So if you get more than 2.4 heads, 2.4 heads and above is significantly high, which is impossible in our case. Based on the result, we conclude that 2 head is not significantly high because it's not more than 2.4. So even 0, because we found for the lower one to be negative, to be too low. Okay. So another way to know significantly high number, X successes among N trials, as a significantly high number of successes if the probability of X or more successes is 5% or less, 0.05. So if the probability is less than 0.05, then it's significantly high or significantly low, depending to where the X is. You compare with 5%. And then if that's less than 5% in both cases, we would say significantly high or low, depending if it's on the lower side of the table, significantly low, upper side, significantly high, compare with 5%. Okay. Expected value. So this is expected value is the same thing as mean. So we already used our calculator. Please write the definition. The expected value of a random variable x is equal to the mean mu. So this is definition. If I tell you what is expected value of this table, then you would tell me, then you put L1 as your numerical values of the list, L2 as your probability, and then you find one var stat. Whatever was the mu or x bar in the calculator shows is the mu. That calls expected value. So I want you to write down the definition and just note to yourself that I use one var stat. X bar, when I read X bar, that's the same thing as mu, and mu is the same thing as expected value. Okay. So mu is the same thing as expected value. So please take a note here. Write it out. Okay. Any question? So let's just read the description of, I don't know how many of you played roulette, but they describe it here as the chances. So let's do that and then create a distribution table for it. So you have $5 to place on a bet in the Golden Nugget Casino in Las Vegas. You have narrowed your choices to one of the two bets. Okay, these are the two bets you see. On roulette, bet on the number 7 in roulette, or in craps, bet on the pass line in the dice game of craps. So far, they are describing the game. They say if you bet $5 on number 7 in the roulette, the probability of losing $5 is 37 out of 38. So, and the probability of making a net gain of $175, net gain means they give you 180, but then $5 was your own, so that's 175. It's 1 out of 38. So definitely you have a much larger chance of losing, and that's with casinos and games, of course. Otherwise, they were not in business. So the price is 180, but when you win, they give you 180, but then 5 of that dollar was your original money. So 37 out of 38 chance of losing your $5, and then 1 out of 38 is chance of gaining 175 net gain. Find your expected value if you bet $5 on number 7 in roulette. So you need to create a table. So in the first one, if I'm creating the table, I would say, do you see me writing? So yes.
Yes.
So if I lose my net gain would be -$5. Do you agree? I'm gonna write -5, but just remember it's in dollars. If I lose my net gain, so let me just say X is net gain. So if I lose, my net gain would be $5, and the chance of that is pretty high, and it's 37 out of 38. If I win, my net gain is 175, and that's 1 out of 38. The chance is 1 out of 38. In order to find the expected value, means in average, what would be your net gain playing putting a bet of $5? Okay, so let's do that. So look at the table. So this is what we developed: X, -5 and 175, PX to be those. I want you to use your calculator. Oh, how did I get -5? I said, going back. So I said, imagine that I have no idea of what roulette is. So this is describing that the probability of losing money. So I said X is my net gain. If I lose $5, what is my net gain? I don't gain anything. I lose money, so it's $5 loss. And the chance of that is very high, 37 out of 38. If I win, they give me 180, but 5 of that is mine. So my net gain here would be 175. So use your calculator, put this in L1, and then put PX in L2. So use your calculator. Did you all copy this one? Because I want to move to my calculator too. So then we can see what is going to be our gain. Net gain. If our net gain is a negative number, that means we're going to lose anyways. If it's positive, means in average you may earn some money if you played multiple times. Let's go and see. So let's go to L1. Okay, let me just go to my calculator. No, because it's open. Okay, so I go to L1 and I have two items. So let's just scroll on L1. I would say clear down. Some calculators you must say second clear down. Some just clear down. Okay, so you would say -5. I'm not sure if the negative should be, yeah, this one. Remember that little negative down here? That's the one. Okay, and then gain would be 175. The chances for -5 is 37 out of 38. The chances for gaining money, it's 1 out of 38. 37 out of 38, yeah. Okay, so now you go to stat, calc, one var stat frequency list L2, or you open a parenthesis L1, L2. In average, no wonder, in average, people lose about more than 25 cents. That means that's more than 25 cents. It's about 26. So that's why casinos are in business, because as you see, in average means many people playing it for the population, they will lose. And I want you to get that idea that in average, people lose about 25 cents per person for the entire population. Someone may win, let's say 2,000, but then another person would lose 5,000 and so forth. But in average, more than 25 cents of losing on people's side. So it's a gain of casinos. Okay. I see a question. What was the second number in L2? In L2, we put 37 over 38 and 1 over 38 based on the table we created. Did you get that?
I got it. Thank you.
You're welcome. I can always rewrite it if you did. Okay. Let's do another example. This one. Okay, now this time I want you to create the table. So this is the second one. That's the craps. If you bet $5 on the pass line in the dice game of crap, the probability of losing $5 is 251 out of 495, and the probability of making a net gain of 5 is 244 out of 295. Still, do you see that losing has a higher chance than gaining? So again, that's how casinos work. So find your expected value if you bet $5. Which of the preceding two bets is a better scene of preceding higher expected value? So now I want you to create, say X and say P of X, this time for craps. So fill it up. And let's see what we get. So fill up the table. For losing $5, -5, the chance of that is 251 out of 495. And then $5 is a gain, 244 out of 295. Sorry, 495. Okay, both denominators 495. Now I want you to put that into your calculator. Please copy this one. So losing 5, gaining 5. Put it in L1 and L2. Okay. So let's just go and put it in I'm going to put it in my calculator as well. Okay. So I go to Stat. You go to Calc. L1, L2. Calculate. Okay. Again. Did you get the same number? So what number did you get for the expected value? Did anyone calculate it? What number did you get? Excellent. So I got the same. So in this case, the chance of losing in average of those who are betting 5 is 7 cents. For the other one, the expected was, so the expected of playing roulette was 0.26. So losing 26 cents, although is more tempting because when you win on that one, your net gain is 175, and this one, your net gain is $5. So you get $10 versus the other one, 180. So people are tempted to play that more, but with $5, average people lose 26 cents. And with $5 in craps, people lose about 7 cents. Okay, which one would you play? Knowing the chances. Will you play craps where you lose 7 cents? Your risk is 7 cents in average, or 26 cents. So 26 cents was for roulette. That was, we did the problem. Expected value of roulette was losing 26 cents when you bet $5. So this is, you have $5. You can bet on roulette with the expected chance of net gain being negative 26 cents. And then on the other one, craps, and the expected average gain to be 7 cents loss. Which one would you play, craps or roulette? Send me your thoughts on this one. So let's read the last page. Craps seems to be a better, at least more secure way of investing the $5. Although when you go to casinos, it's not much of investment, but you need to think of which one has a less chance of losing money. So please read this page, and then craps will be a better game to play in a long run. Okay. If you're playing it once, you probably play roulette, because if you gain a lot. But if you are playing over and over, definitely craps will be a better one. Okay. That's all for this section. How are we all doing? Okay, great. 5.2 is binomial probabilities. So I hope you wrote the calculator command for this one. Binomial probabilities, I put calculator commands where you can look at the examples after class, and I highly suggest it. So assignments for 5.1 and 5.2 will be due on Thursday. So in 2 days, I'll activate it after class today. So I want to give you 3 minutes of break. So maybe just get up, walk around, and come back. This is 10:03 on this computer. Come back in 3 minutes. Marina, in order to enroll on MyMathLab, it doesn't show on my side, but when you log in, it says upgrade access. You click on upgrade access and you pay with your PayPal or credit card. So that's how it goes. You can stay after class and share your screen with me. But it's just before you click on the course, when you go to the tabs on before saying entering the course, as soon as you log in, it says upgrade access, and that's where you do it. Or if you purchase the access code from DVC Bookstore or any other places, then you just enter the access code. So you go to gradebook. The gradebook on MyMathLab just tells you your grade on the exams and quizzes, but I import all of them to Canvas. So you should see updated gradebook tonight or tomorrow for exam one. So, but you can always click on the gradebook on My Math App because I already graded on My Math App. I just need to import them to Canvas. Okay, take your 2-3 minutes break and okay. So now let's get it started. So this section, the second section of chapter 5, so chapter 5, 2 sections, the previous one and this one we cover for the course. The focus of this section is binomial probability distribution. And there are easy methods to find mean and a standard deviation, which I give you formulas for this one. And we have a calculator command for the probability itself. Okay. Binomial probability distribution results from a procedure that meets these 4 criteria or requirements. So from now on, you need to recognize what probability we are doing. The problem has what model. And then from there, you decide what formulas or calculator command use. So write binomial probability distribution on your note. For the binomial probability distribution, the procedure has a fixed number of trials. Means like if it's 10 number of trials, 5 number of trials. So there are fixed number of trials. So that's number one. The trials must be independent, meaning that the outcome of any individual trial does not affect the probabilities in the other trials. So write independent. So fixed number of trials, independent. There would be two categories in each trial, right or wrong, success or failures. So exactly two category as the outcome of the observation. The probability of success remains the same in all trials. So that means, let's say you're talking about a multiple choice test. All the questions have, let's say, 4 parts, A, B, C, D, and your chance of getting it right is 1/4 if you're guessing. So the probability, not that one of them has 4 parts and the other one has 5 parts and so on. Okay. So some of notations. P is the probability of success. Q is 1 minus P. So whatever is not success, of course, is a failure, is a complementary to P. Notes by Q. And N is the number of trials. Okay. X is the number of success in N trials. So X should be a whole number anywhere from 0 to N. If you say the test has 10 questions, what is the chance probability of I get 4 questions right? So 10 questions that the test has is N. Let's see where I put my pen. So here we go. Let's say you have a multiple choice test. Probability of success in one trial, let's say that it has 4 choices. So probability of getting it right is 1/4. Probability of getting it wrong is 1 minus 1/4, which is 3/4, the remaining of 1/4. And then let's say there are 10 questions in the test. N is 10 observation, and you can ask for a specific X. You can say, what are my chances of getting exactly 5 questions right? Or what are my chances of getting 5 or more questions right? Or what are my chances of, for all of them, you can write P of. What are my chances of getting less than 1 question right, or less than or equal? Means getting 1 right or no right. Okay, so write the notations. Okay, yeah, of course, you all know that the word success that was used in this class, or favor, is an arbitrary name. Sometimes we say, like, what is the probability of death when skydiving? That doesn't mean it's our favor. It's just arbitrary success for the problem. It's not something good. So I just want you to know that. Okay. So let's read this question. And then identify N, X, P, and Q in this case. And think about if it's a binomial distribution, A and B. So please read the question. Think if it's a binomial distribution. Go back to the requirements, check, tell me yes or no, and then tell me what is N, what is X, what is P, what is Q. N, X, P, Q. I'm expecting that to come through chats. Okay, I give you 2 minutes. That's right so far, Mustafa. So please send me what is X, N, P, and Q. That's great, Marcus. So identify, it's very important to be able to identify these items. Indamola, that's great. Oh, actually your X is not Indamola. Check your X. Mustafa, your Q is right. Your X is right, Indamola now. Okay, please send me what you think is N, X, P, and Q. Can I have a volunteer to read the question?
I'll read it.
Go ahead, please.
You want me to do the whole thing?
Please, yes.
Okay. Example, Twitter. When an adult is randomly selected with replacement, there is a 0.85 probability that the person knows what Twitter is based on results from a Pew Research Center survey. Suppose that we want to find the probability that exactly three of five randomly selected adults know what Twitter is. Does this procedure result in a binomial distribution? If this procedure does not result in binomial distribution, identify the values of nx, p, and q.
Thank you. So let's check the requirements. The first requirement was, tell me this is good. I'm not sure about your P and Q, but let's just look at the criteria or the requirements. Has a fixed number of trials. So in this case, there are n number of trials, and that's 5. So that's checked. Each trial is independent of the other one. One person knowing Twitter or about Twitter is independent of the next person knowing about Twitter or not. So that's independent, so that's checked. It's a binomial distribution, means you have two categories of success or failure. Either they know it or they don't know it. So that's a yes or no. And then the probability of success is 0.85 throughout. So it's for every person, there is a possibility of 0.85 knowing it. So yes, it is a probability distribution. And as many of you answered, N is 5, X is 8. What is the probability? Exactly 3 of them out of 5 you randomly select. No Twitter. P is 0.85 and Q is 1 minus 0.85, which is 0.15. Okay. Any question? So we did that. Now that we want to find that probability, I want you to grab your calculator. This is So you're gonna have you're gonna go to distribution. I'm gonna show you where that is. Let me clear everything. So let's do it again. So you go to second, and do you see above vars it says distribution? So I'm gonna keep vars as the key next to clear. Second vars is distribution. So do you see I write it in the key history here? Then you scroll down. Please pay attention to this part. There are two options here. Binomial PDF, binomial CDF. When you say exactly 3 out of 5 to be whatever that is. So when you say exactly 3, exactly 2, when you're looking for exact, you use PDF. For the CDF, so when you would say like 2 or less, 5 or less, whatever number, X or less, to be like, if I was saying, what are the probability that less than 3 people knew about it? So then you would have used CDF. So make a note here. Okay. So now let's do this one. This particular problem is exactly 3. Click on PDF, no binomial PDF. Number of trials was 5. P is 0.85. And then X is 3. Those of you who do not have the layout the way that I do have it here, after you press binomial PDF, after you press on it, open a parentheses, say N first, P next, and then X last. So say 5, comma, 0.85, comma, 3, and close the parentheses. So everyone do that and tell me what you get for binomial PDF. So that's going to be the probability. So N, comma, P, comma, X. Please write that somewhere in your notebook. No one was born knowing this command. You really need to practice it. You need to write it somewhere. So that means practice will make you better on that. Excellent. 0.138. So there is about, if I was rounding this one, there is about 14% chance that you pick someone. This is if you round it, it's going to be 0.14. If you look at this one, the next number is 5 or more, so you round it up to 0.14. So there is a 14% chance that the person that you select 5 people and exactly 3 of them heard about or know about Twitter. So binomial PDF n comma p comma x. Okay. Steps to get binomial PDF, someone asked. Here we go. Let me clear it. You go to second distribution. You can also see it in the history. Do you see the keywords? Second wars, and then you go down because it's exactly 3 out of 5. You pick binomial PDF versus CDF, and that's 14%. Then you click on it. And then N, P, and X. It should look like that, 5, comma, 0.85, comma, 3. And then you get it. Okay. We haven't used CDF yet. We're going to do it in another example. So PDF is for exact. Oh, we use it when it's less. When you say less than, the probability of less than 2, know about PDF. No about Twitter. Okay. So we did that. We did that. Okay. They have ways of calculating using formulas. We don't need that. We have our calculator, and here is magically the answer appears, 0.138, which we rounded to 0.14. So the probability of getting exactly 3 adults who knows Twitter among 5 randomly selected adults is 0.138, or about 14%, or 0.14. Okay, you don't need to know the formula. You can use technology. Okay, we don't need these. Okay, so please answer part A. Based on the Harris poll, 60% of adults believe in devil. And then now I want you to tell me exactly 3 out of 5. What is the probability that exactly 3 of 5 adults believe in devil if you randomly select those? So it says exactly. So on the test, you're going to tell me binomial PDF, and then you're going to tell me what you type in. So 5, comma, the chance of believing is 60%. You always need to put it as a decimal. And then comma, the number of trials. So NPX. Okay, so do that. And tell me what you get. So please do that and send it to me. So send me your answers. I'm waiting to see what numbers you get for the binomial PDF. And then I share my screen with you again. So send me your answers. یه روزی علکی بزنم. Send me your answers. I'm waiting. Okay, so great job. So now let's go to the second part. Let me share my screen again. Now you have the probability of adults who believe in devil is at least 2. So at least 2 means what? Means it's 2 or it's 3, x equal to 2, x equal to 3, or 4, or 5. So at least 2, 3, 4, 5, when it says at least 2. So you can say, you can put that in your calculator as normal PDF of each one. So binomial PDF, binomial PDF, binomial PDF, binomial PDF, and add them. Or let's talk about what is CDF. CDF tells me for not, this is 2 or more. CDF always is less. If I find 1 or less, do you agree that's 1 or less is complementary event to this one? 1 or less is complementary to 2 or more. So I can find 1 or less using normal CDF, binomial CDF. So you go binomial CDF, and then you go with the formula of n, that's 5 trials, 60% chance, and then 1. If you say CDF and you put 1, means 1 or less. This is a complementary to the event to the probability you're looking. So whatever you get here, you would say 1 minus that would be equal to that probability. So you find the complementary probability, and then you say 1 minus whatever I get will give me P of 2, 3, 4, 5. So that means going to always CDF is for less. So here's what you do. You go to second distribution, go to normal CDF, number of trials is 5, 60%, N is 1 for CDF because we said 1 or less is complementary to 2 or more. So then you go paste. The answer to that is 0.087. So I said we say 1 minus the complementary 0.087. So that would be 0.913. So there is a possibility of 0.913 or 91% that out of 5, 2 or more know about Twitter. Makes sense? Do you see where we use the CDF for? CDF would say 1 or less, 2 or less, whatever you have, or less. And then if you're looking for less, then that's the final answer. If you're looking for more, you would say, oh, what is complementary event to this one? So that's the main idea of today's lesson on 5.2. So here we go. So they did it with formulas, but the final answer is the same as ours. So that's the probability of at least 2. Again, you could have used PDF, 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 PDF of all these. These are the PDFs of each. And they add it together. Or you could have say 1 minus binomial CDF of 561 or less. And that's a complementary to 2 or more. Okay. So here for binomial distribution, I want you to know these formulas. These are not obtainable by calculator. So the mean or expected value of binomial distribution, you need to identify N, P, and Q. I don't know why my pen is blank. You would say N in this case is 5, P is 0.6, Q of course is the remaining of 0.6 is 0.4. Then you can find everything. So mu is N times P. So that's 5 times 0.6. 5 times 0.6 is 3. And then variance is N times P times Q. You multiply them together. It's 3 times 0.4 is 1.2. So that's, give me a second, please. Give me a second, please. Okay, so you multiply N and P, you get mu. So that would be, again, in this case, 5 times 0.6, that's 3. You multiply N times P times Q, and that's 1.2, that's the variance. If I did the calculation in my head right. And then you would say to find the standard deviation, you use the square root of whatever you find here. Square root of 1.2, which I can share my calculator with you, and you see how to find them. Okay. Oops. So you would say square root of, so square root of 1.2, it's 1.095. And that's the standard deviation for the population. So just know the three formulas. And again, to find square root, just see second, and the square is a square root. Do you see the blue sign for square root? That's what you put there. Okay. So just quickly for the rest of the items, remember that significantly low and high, the percentage could be compared with 5%. Oops. Give me a second, please. So you find a mu and 2 standard deviation below and above is going to give us being normal or not. So exactly like the past, mu minus 2 standard deviation, mu plus 2 standard deviation is not significantly high or low, it's within. And then anything above or below these numbers are significantly high or low. You can always compare with 5%, and you don't need to know this formula because your calculator gives it to you. Okay. Let's just do this calculation, each of us on our papers, and then see if we get a matching answers. Okay. Oops. So I want you to answer part A, find the mean and the standard deviation of number of wins of 460 games. N times P is the winning mean. Standard deviation is the square root of N times P times Q. Bring the formulas, answer part A and part C. Part A, forget about B, part C. Part A and C. So use the formulas I gave you. Please write down these formulas and then use those formulas. Did you already write down these or take a picture of them? Remember, if you don't know the formulas, there is no way that you'll be able to answer questions. So write them down. And then we're going to use 2 below and above to see if it's normal or not. Okay? So find the mean and a standard deviation of 460 games. And please send me your answers. Again, that's how I know that you are participating. Okay, to find the mean, great job to those who are responding. Mu is n times p, so it's 460 times 0.5, 230. So in average, 230 of the game will be winning. And then a standard deviation is the square root of n times p times q. So you find those. So and the answer to that is 10.7. And then the unit, of course, is the same thing as games, as the number of games we're discussing here. Okay. So now to know what is significantly high or low, you would say mu. You go 2 standard deviation below, so that would be 230 minus 2 times 10.7 and plus. So that's mu minus 2 standard deviation plus 2 standard deviation. If they play less than 208 games, then that's significantly low number of games. And then if they win more than 251, then it's significantly high. Make sense? Any questions? So significantly low number of wins are 208 game, 0.6 games or fewer. High is more than the 2 standard deviation. Okay. And that's 252 games. So the ones that says part B, I still want you to know it. So please do it. The result of 252 is above 251.4, so it's significantly high. Okay. Any question here? Any question? Okay. So again, you don't need to know the formula. That's all for today. I will put the homework up soon. Any question?